Hey, it's Aaron, and this is part 2 of fuse testing. In our last fuse test, as you might remember, we ran into a bunch of problems on launch day that almost made us give up a bunch of times. That test ended up with the first stage engine successfully igniting the fuse, but the second stage ignition was unsuccessful. It ended up being fun solving the problems and pushing through them, but we can all agree that we didn't want to go through it again. We couldn't possibly run into all these problems again, right? Anyway, after the last fuse test, the clear plastic tube wasn't so clear anymore, so we blasted hose water through it. As you can see, this actually worked pretty well. It wasn't perfect, but at least we were able to see through it. Next, we needed to decide what improvements we wanted to make to try to get the fuse to successfully ignite the second stage. We chose a fuse that was twisted up tighter at the tip, which, as explained in the last video, added an extra small explosion at the end of its burn. We also changed the first stage engine to a tiny A34 and the second stage to a B66. These weren't really improvements, just small design changes that should be noted. Because an A34 has a smaller diameter than an A83, which we used for the last test, we also had to 3D print an adapter to hold the small engine in a larger diameter tube. On launch day, I wanted to check if our brand new launch controller was working, because one of our problems from the last test was that all 3 of our launch controllers weren't working. And guess what? The brand new launch controller that I had just taken out of its plastic wrapping was not working. To me, this was so ridiculous because these launch controllers are such simple circuits, and this company has been making them for decades. There was no point in complaining though, so I decided to build my own. I cut the wires with the alligator clips off the new launch controller and connected them to a switch and a 9-volt battery, which is what the real launch controller was supposed to use. I tested the circuit on a motor, then an engine igniter, and it worked. We then went to the school to perform the test. As you can see, our new launch controller didn't work.
Flip it back.
Yeah, flip it back. We then took out the igniter to see if it had burned at all, but it was only partially burned. We thought this might have had something to do with the battery, which was already used for something else, so the next day, we bought some new 9-volt batteries and tested them on another igniter. From this video, you can see that the igniter actually burned pretty well, and it looked like it would work. Unfortunately, I don't have any video of the igniter test with the controller using the old battery, but this definitely burned flamier. The igniter also burned all the way, unlike the other controller.
5,
The next day, we went to the school to try again.
2, 1.
You can actually hear the igniter burning, but again, no engine ignition. After examining the igniter, it was only partially burned again. At this point, we decided we would just do what we did last time. Attach a controller's wires directly to 4 AA batteries. We also changed out the first stage engine because we were afraid that the partially burned igniters had damaged it, and later, we actually did find something weird with it, but that's for later. Finally, almost 2 weeks later, we fired the engine. Again, the fuse ignited, but the second stage didn't, which was sad, but it was kind of fun seeing that Astros hat burn. At this point, I'm almost ready to give up on Falconry 1 and move on to other projects. The reason I say this is because Falconry 1 isn't really going to be a building block for what I want my next projects to be, except for maybe improving my rocket building skills. The whole point of this project was to see if we can build a 2-stage rocket with a large gap between the stages, and use the ejection charge of the first stage engine to ignite the second stage. We have proven this is possible with some of our tests, but it was never consistent. It being hard isn't necessarily the problem. If you can't get it to be consistent, it won't work. I did say almost ready to give up, so that being said, there's one more thing I would like to try. After our 7th static fire, we said we would try to ignite the second stage using a fuse. We wanted a quick burning fuse, but we couldn't find any on the internet, so we made our own. During our research, though, we did find a fuse that was made specifically for model rockets. The reason we avoided this was because it was made to be slow burning, but what I'm wondering is that if we made the fuse thinner, kind of whittle it down with a knife, will it burn quicker? maybe we don't even need to make it thinner. The reason our fuse didn't work could be because it burned too fast. I honestly think it's worth a try. I don't want to give up on Falcon 1 when we've already invested so much time and money into it, and thinking that maybe we could have gotten it to work. Anyway, remember that first stage engine we switched out because we were afraid it wouldn't work? Here's a video of us firing it. Weird, right? Let's see it again. Actually, all of us, except for my brother, we were looking up at the sky because we had thought those little streaks coming out of it was the engine. In reality, the engine bounced away and my brother was the only one who noticed that it didn't fly away. I'm happy we didn't end up using this engine for the test. It could have ended badly, and it wouldn't really be a controlled experiment either. But it was cool. Stay tuned for our next videos with the new fuses, and make sure to like and subscribe. Bye.